Hi everyone, welcome back to our YouTube channel. Today, what we'll be doing is find the sum of the given series. Find the sum of the given series. And just to remind us that these questions are questions that you can easily see on checks. When you check online, you will see it on checks, see the question on checks, but the solution will be hidden. But here, you'll be getting the solution for free. All you just need to do is subscribe and start getting your free solutions to your advanced engineering problem. So without wasting much of our time, let's look at the questions today. So I finding the sum of two given series. So the first one we're finding the sum of minus 1 raised to power n times 4 raised to power n x. Don't make the mistake, this is x not times, this is x raised to power 8n all over n factorial. So now we're going to be finding this sum, and this is quite easy and straightforward. We're not going to waste much time on this question because it's very straightforward. So this is an hidden form of the exponential function. That is, when you the exponential function, let me say e of x, when it's been expanded using Taylor's expansion, you get something like this. Let's say, let me use e of z, you get something like this. So this is exponential function when expanded using the Taylor's expansion method. So now if we check this and we check our given series, we will see that there's no much difference. There's no much difference at all we just need to do is find what that z is in terms of the given series. Then we do a substitution and we'll get our final answer. So now let's try and simplify our given series. So what we have here, we can write this as minus 4 raised to power n x raised to power 8n over n factorial. I can write this as this, and as well I can say when we have minus 4x8 raised to power n all over n factorial. I can also write it as this, that is minus 4x raised to power 8 all into brackets n power, then all over n factorial. Then if you go back to our exponential function that I gave us earlier, the exponential of z, which is z raised to power n over n factorial. So everything inside this bracket represents our z. Everything inside this bracket is our z. So what we just need to do is now let's write rewriting it for better view. So we can say z equals minus 4x8. Then going to our exponential function, z power n factorial. You can see that it's the same thing as this. Inputting our value for z, consider this is just 4x8 over n factorial, which is e 4x power 8. So now the sum, our final answer now, the sum n is equals to 0, 20 minus 1 power n 4n x 18 n factorial is equals to e 4x8. So this is our final answer for the first series. Now moving to the second series given in this question. So we'll be looking at this series. The series is 7 times minus 1 power n pi e to power 2n plus 1 all over 2 e to power 2n plus 1 times 2n plus 1 factorial. So let's go ahead with this as well, using the same idea as what we did in number one in the first series, I mean. So now we'll be looking at this 7 is a constant, it's standing alone, so let's bring it outside of the sum. So let's go ahead and do that. Our infinity, then we have this pi 2n plus 1 all over 2n plus 1 2n plus 1 factorial. So this, what again can we do? Let's try and do some manipulation. This pi and these two, they are having the same power, so let's do some work on that and give it something like this. So we have pi over 2 2n plus 1 all over 2n plus 1 factorial. Now at this stage, what should be going on in our mind right now is that it should remind us of another popular and common function. This is just another Taylor expansion of a popular function. This should remind us of the sine function. Let's say sine function of z, which is 0 infinity. We have minus 1 n. Then we have z 2n plus 1 over 2n plus 1 factorial. Just like we did in the first series, same thing is going to apply here. When we try and check this standard sine function, that is the Taylor's expansion, then check our given series, we see that they both look alike. The only difference is that our series has a constant 7, which is actually outside the sum, which is nice for us. Then our our z here is pi over 2. So now, which is very easy for us to be able to manipulate our way around. So we have 7 0 n pi over 2 2n plus 1 all over 2n plus 1 factorial. And from what we said earlier, so don't forget, this means our z now is pi over 2. So this gives us 7 times sine pi over 2. So it gives us 7 sine pi over 2. And we know that 7 sine pi over 2 is going to give us 7 times 1, because sine pi over 2 is 1. So 7 times 1, which is 7. So writing our final answer now, we have 0 infinity 7 minus 1 n pi 2n plus 1 all over 2n plus 1 2n plus 1 factorial, which is 7.